Welcome back to another episode of Holistic Game Development. Right, in this one we're going to look at something that's very cool, and that is physics. The great thing about the physics system in Unity is that you can get something animated and working without doing any scripting at all. Physics system require two components that work together to get you the interactions that you see on the screen. First, there's a collider, which defines the outside of an area and how sort of big it is. And then there's the rigid body, and it's the rigid body that's actually doing all the physics number crunching for you. So the best way to explore this topic is to actually do it in Unity. So I've created a new scene here. Now I've still got my chair that I've been using previously, and we'll come back and try and put some physics onto the chair a little later. But first, just look at the basics. So over in the hierarchy, what we're going to do is to right click, go down to 3D object, and we're going to add in a sphere. So just a basic sphere. I'm just going to select that sphere. Now when it gets created, it's probably going to be like at 0 in the Y direction, okay, which is like on the ground. I'm just going to lift that up like there. And then we're going to create a plane. So right click, 3D objects, and let's go plane. And the plane will be created at 0. If it's not, you can of course move it around. Why I want it to look like this is so that I can actually get gravity to work on the ball, because that's part of the physics system. So we can see the sphere. I've already created a little red material here, and I'm just going to drag and drop that onto the sphere. Alright, so what are the components of the physics system? There's colliders and there's rigid bodies. By default, if you create one of the Unity base objects, it comes with a collider. Selecting the sphere over in the inspector, we can see that there's a sphere collider added onto it. And there's a whole bunch of different colliders of different shapes that you can add and kind of put them together to fit your actual object. We'll have a look at that later on when we do the actual chair. And if we select the plane, there's also a mesh collider on there that is covering and defining where the plane is. It's probably easier to see on the sphere itself. If we select the sphere and then hit the F key over in the scene, you'll see that there's a green line going around this sphere. That is the actual collider of the sphere. So it's defining where the sort of physics boundaries of that sphere are. At this point, there's no physics as such, or no physics system as such to make gravity have that ball fall. But it is a collider in the physics system. But essentially it's fixed. So you could think of it like, a wall, that you never want the wall to move, but you still want it to interact with other objects that might be hitting it. So it has a collider on it. It's the same kind of thing with the plane down here. We don't want the plane to move at all. So we don't want it to fall under gravity. We just want it to stay still and have the ball hit it. Right, so how do we do that? Well, we need to add the essential component of the physics processing, which is called a rigid body. Select the sphere. Over in the inspector, we're going to go to add component down the bottom here. Now there's a whole bunch of different components that you can add to objects, and the more you use Unity, you'll find that it's very component based. Start typing in rigid for rigid body, and you'll see there's two. There's one for 2D objects and one for 3D objects. Select the rigid body, which will then be added into your hierarchy onto your sphere. Now, at this point, you have a physics system set up. Let's press play and see it running. Okay, so there you saw the physics system. The sphere acts like a ball. It falls with gravity applied to it onto the plane. The plane doesn't actually move at all. Now, interesting enough, what do you think would happen if we added a rigid body to the plane? Let's just do that and press play again and have a look. And now you can see that they both fall under gravity. All right, so we're going to take that rigid body off of the plane. Something very, very important at the moment that you should take notice of is to stop the simulation running before you make any changes, because you can actually make changes while it's running, which is great, but when you hit stop, all those changes go away. So make sure that you do that. Now, this is something you'll just get to learn how to do. Trust me, I still do it and make a lot of changes while it's in play mode, which is a really bad thing to do, but you'll get used to that fact. Okay, so let's come back to our plane. Now we're going to go to the rigid body on the plane, and we're just going to click on these three dots here and remove the component. Now that menu that comes off is actually off the screen, but this second one down here is actually remove component. All right, so that gets rid of it, and now we've got just the sphere that's going to move under the weight of gravity, or the force of gravity, I should say. Right, now what you might be thinking at this point is, how do we make it bouncier? Well, to make it bouncier, you need to create what's called a physics material, and the material actually goes into this little slot here on the sphere collider. It's the material that determines the sort of physics properties of the object itself. The rigid body, if you have a look at the values in it, like mass, it's kind of the values that are defining the actual physical structure of the object, but the material allows you to define how it's going to interact with other objects. Right, so let's create a new material. Now I've already got a new material down here in my models folder. It doesn't really matter where you put it. Probably should put it into a physics materials folder. So let's just go back to assets, and we'll go create folder. Let's just call it physics. And then in there, I'm going to create. So right click, create. Now you want to come down the list here to physics material, which is off the screen for you, but you'll see it down the bottom there. And that creates a physics material. Now we're going to call this bounce, because if you remember, that sphere just falls and doesn't do anything. It just hits and stops completely, because there's no definition of what it should do when it hits something else. Okay, so we come over to our sphere now. We get that bounce material, and we're going to drag and drop it into the material there. So drag and drop it to set the material. You can also, besides drag and dropping, you can hit this little target button here, and you'll get a window that pops up and shows you all the available materials. You can see that one I created a little bit earlier, and then set the one you want. All right, so we've got our bounce on there. Now this bounce is the default new material, and if we have a look at it, it shows you a dynamic friction, a static friction, and a bounciness value. All of these settings in the physics system we'll actually go over in a lot more detail when we look at physics in detail. This video is just sort of an overview of what you can do. Now, bounciness is set to 0. We want bounciness to be 1, like very bouncy. So this value is only between 0 and 1. Okay, so now with that set, let's have a look how bouncy our sphere is. So if we press play, wait for that to run, and here we go, bounce. Okay, so it's bouncy. Now, it can't be any bouncier than what you've just seen there with this particular setting. But you can actually use this bounce combine value to figure out how that sort of dampening effect of the bounce is going to happen. So at the moment, it's averaging it. If we set it to, say, maximum bounce, and I've just done that not in play, so if I turn that off, okay, luckily for the material, I actually kept it, so that's good. So with maximum bounce, let's now play this and observe the bounciness. So you can see that the bounce doesn't dampen like it did before. And in fact, if you look closely, it's actually getting higher and higher. So these combined values, and we'll look at those in a lot more depth when we look at physics in more depth, actually is a calculation between the hit, I guess. So between whatever the physics is on the plane and the ball, it is going to retain the maximum value of that particular hit. And in this case, when it's getting calculated, it's actually calculating a higher maximum value, and it keeps adding to it, as you can see there. All right, so feel free to play around with that, because it's quite fun just to play with the settings at this point. One last thing before I end this video is to talk about the colliders. So we remember that we have a sphere and it has this little green collider around it. we can change the size of that particular collider. So over in the inspector, let's look for sphere collider. Now we're going to come down to the radius of the sphere collider. This is the value that you can modify for how big that is. And if I change it, so just put the mouse down next to that input box and drag it with the right mouse button down. With the left mouse button down, you can actually change it. So if I make it a little bit bigger, like, you know, like that, that is going to be where the collision occurs with the plane. And if we drop the ball now, so let's just press play, you'll see that you don't see the model of the ball actually hit the bottom. It hits its collider. So you can see that the sphere doesn't actually ever hit. It might be a little bit hard to see at that point. If we make that sort of outrageously large like that, okay, and let's press again, you'll be able to see where the sphere collider is doing the hitting. Yeah, okay, so now it's not actually hitting the ground. You can see that the shadow's not making contact with the actual sphere, its collider, and the values on that. With the collider, just out of interest as well, you can actually move where it is. So if we change its Y value, you can actually move it so the collider is sort of up there. Now, can you predict what's going to happen when I press play? Because the collider's up here, the collider has to keep moving down until it hits the plane, which means that the model of the ball is actually going beneath the plane. And for this, it actually gives you a bit of an effect where the ball is squashing at the bottom, which is a sort of an animation effect. Because when you throw a ball at something, if it's kind of a soft, squishy ball, it actually does, you know, squish into the ground like that. All right, so that is the basics of the physics system. I'm going to come back in the next video because I said I would do a physics on that chair that we've put in before. So stay tuned and I'll show you how to put physics onto an object that you've brought in from outside.